knows a lot about the science stuff. Professor Dave explains.
Before archaeologists can excavate a site, they need to know where to dig. Archeological surveys are the techniques used to locate material remains. It is common for an archaeological study to end after a survey, since knowing where sites are in a region can tell us a lot, and is also less time-consuming and expensive than full excavation. Surveys start big and get smaller, moving from regional survey to site-based surveys. Surveys can be full or targeted. Full surveys use the same technique over an entire region, perhaps sampling in a grid or using evenly spaced transects. Transects are lines of survey with space around them. This is very useful as it is a more unbiased survey. However, it is much more time-consuming, often with much of the survey finding nothing. Targeted surveys target areas of high probability. An example of this would be only surveying river valleys of a region, since human habitation is much more likely there. You are likely to find more sites with this method, but it prohibits you from making claims about the region as a whole, since lower probability areas weren't included due to bias from the surveyor. It is also important to note that a full survey means the whole area was equally sampled, not the entire area itself was sampled. In modern archaeology, a regional survey relies on geospatial technology, or technology that creates aerial maps. Satellite data is used to understand the topography of regions. Sometimes, cultural remains can be seen from satellite view and are recorded in this way. This is the case in places where people built large structures in areas with little erosion and foliage. Geospatial surveys also use plane and drone imagery to capture more accurate and higher resolution images. Geospatial surveys don't always use visible light images. One of the most helpful survey techniques is LiDAR, which stands for light detection and ranging. A LiDAR scanner is mounted to a small plane or drone and flown over a survey area. It shoots millions of UV, visible, and infrared lasers toward the ground. It is able to detect changes in the return of those lasers, creating a highly accurate map of the ground. A fraction of those lasers are able to pierce foliage layers and even a few centimeters of soil. If archaeologists discard the lasers that hit foliage, we can make highly accurate maps of the ground underneath trees and brush. This has led to incredible discoveries, like in 2018 when hundreds of Mayan sites were discovered in a LiDAR survey of the Guatemalan jungle. Moving down the ladder from bigger to smaller surveys, we arrive at pedestrian survey. Pedestrian survey involves a person or groups of people walking in transects in an area. Archaeologists will slowly walk looking for artifacts and features on the surface. This is why being able to identify them easily is so important. Artifacts would be marked with a point on a map, and archaeologists use density maps of those points to determine the possible location of sites. However, what about areas where brush and grass cover the ground, preventing survey? Archaeologists use shovel testing to survey these areas. Shovel testing involves digging holes to a sterile layer of soil along transects with a set distance between them. If an artifact is found in a shovel test, others are dug in the vicinity to delineate possible sites. Pedestrian surveys and shovel testing are often referred to as Phase 1 surveys. Once an area of a likely site has been identified, we move to site-based survey techniques. These surveys give archaeologists clues as to where to excavate at a site by remotely detecting artifacts and features. One of the most popular methods is the use of a GPR, or ground-penetrating radar. Pushed along the ground, a GPR sends radar pulses to find discrepancies in soils. Since GPRs are used in areas already highlighted as a probable site, these discrepancies are often interpreted as features. Another method is through magnetic survey. Metal detectors are sometimes used if metal artifacts are expected. More broadly applicable are highly sensitive metal detectors called magnetometers. Magnetometers are so sensitive they can detect trace metals in materials like rock and charcoal. Archaeologists look for magnetic anomalies, which might be piles of rock, middens, or hearths. Finally, an often overlooked survey method is local knowledge. Humans live all around the globe, and archaeological surveys often take place in areas already inhabited by peoples who have been living there for hundreds of years. They are sometimes aware of archaeological sites in their area unknown to academic literature. Working with local communities is one of the main focuses of modern archaeological theory, and learning more about local knowledge is just one of the benefits of this. After an archaeologist has completed a survey, they now know where probable sites are and where to excavate in them to find artifacts and features. With surveys understood, let's move forward and look at how archaeologists perform excavation.
Thanks for watching. Subscribe to my channel for more tutorials. Support me on Patreon so I can keep making content. And as always, feel free to email me, ProfessorDaveExplains@gmail.com.